So in this video, I'm going to discuss the minimum operation to maximize last element of the array. So if you have any doubt regarding this, you can ping me up on Instagram. Even you can join my Discord server. I provide both the links in the comment section. I'll pin them. So the problem statement is very simple. What you can do is you can swap. You're given two arrays of same length, so you can swap them. Swap every element any number of times you want. I mean, actually one time. That is like, so you have to find the minimum number of swaps such that the last element of every array is greater than all the elements of that array. Okay, so for this case 1 2 7 4 5 3. So the best approach will be if we swap 3 and 7. So this becomes 3 and this becomes 7, right? Now see, 3 is greater than 2 and 1 and 7 is greater than 4 and 5. So how many operations required? 1, right? And for this similarly, the best approach will be, if you like look into this very carefully, it will be swapping these two. That is, this becomes 8, sorry, this becomes 8, this becomes 3, this becomes 2, this becomes 8. Okay, see, 9 is greater than all of them and 4 is greater than all of them. Okay, now so this is the, you need two operations. This is the minimum. Okay, this is the minimum possible, and over here if you look carefully, there is no possibility to do so. Okay, so we return -1. Now how we are going to do this? So there is two options. Either we are going to swap. So there are two cases. Okay, case 1, case 2. Case 1 is swap last element, and case 2 is don't swap last element. Okay, so for this, so let's say number of steps, it is actually initially 1, and for this the number of steps is initially 0. Why it is 1? Because you are swapping already. Okay, so we are already investing one step in that swapping of the last element. Now once we are done with this, so we have to check. So let's say this is maximum 1 and this is maximum 2. Okay, and if we swap this, so the values of m1 and m2 gets reversed, right? It gets reversed. And if we don't swap this, so m1 and m2 remains as it is. Okay, now it is very simple. Run a loop from 0 to n minus 1. Okay, and check if nums1 of I is lesser than equal to m1 and nums2 of I is lesser than equal to m2. That is, both of them are smaller, so we don't need to swap them. Okay, so we can do what? We can just continue, okay, with our operations. But if the opposite thing happens, that is n2, that is else if n2 of I is lesser than equal to m1 and n1 of I is lesser than equal to m2. Okay, that is, by swapping, that is, initially these conditions are not satisfying, but if we swap it, the condition satisfies. So we can do what? We can make steps plus plus, right? And if neither of them is satisfying, so else we can say that the flag is equal to 1. Okay, so obviously there was a flag of 0 over here also and over here also. Okay, now this thing you have to perform for this also and this also. And once you're done, so over here the flag was called flag 1, let's say, and over here the flag was called flag 2. So this is going to be flag 1 or 2. Okay, whatever it is. Now see, if both the flags are 1 equal to 1, so we are going to return -1. If either of them are 0, so we have to return whichever is having a 0. Correspondingly we have to return the steps. Okay, so over here let's say steps 1, steps 2. Okay, something like this. So, and if both of them are 0, return the minimum one. Okay, so over here if we check 1 2 7. Okay, now let me do it with a bigger one. Okay, so 2 3 4 5 9 and 8 8 4 4 4. Now let's talk about steps 1. So it is initially what? It is initially 1. Okay, why? Because we are already swapping these two. That is, this becomes 4, this becomes 8. Okay, clear? Now check 5. 5 is lesser than equal to 4. Nope. Now you have to check the opposite thing. That's 4 is lesser than equal to 4 and 5 is lesser than equal to 8, right? So we can swap them. So swap them, 4 and 5. Okay, so steps becomes 2. Now see, 4 and 4, this both of them satisfies. This both of them satisfies. This both of them satisfies, right? So what is one possibility over here? That is 2, right? Steps 1. Now we are going to do the same thing again. 2, 3, 4, 5, 9 and 8, 8, 4, 4, 4. Now what we are going to do, steps 2. Okay, steps 2. So it is initially 0. I told you it's initially 0 because we are not swapping the last elements. Now check from here. Okay, 5 is lesser than equal to 9. Yeah, 4 is lesser than equal to 4. We don't need to check it. 4 is lesser than equal to 9. 4 is lesser than equal to 4. Yes. 3 is lesser than equal to 9. 8 is lesser than equal to 4. Nope, it is not satisfying. So we are going to do the reverse thing. 8 is lesser than equal to 9. 3 is lesser than equal to 4. Yes, this satisfies. So we make it 8, 3. So this becomes 1, right? And again the same thing. 2 is lesser than equal to 9 and 8 is lesser than equal to 4 doesn't satisfy, but 2 is lesser than equal to 4, 8 lesser than equal to 9 satisfies, so we swap them. Okay. 2. Now what is the maximum, what is the minimum among them? 2. So we written 2. For this 154, 154 and 253. So let's say first we are going to do 3 and this 3 for 4. So steps 1 is equal to 1. Now see, 5 is lesser than 5 is okay. Now see, if we even reverse check this, so this is not happening. So what we are going to do, flag 1 becomes 1. Okay, now do the same thing. 154, 153. Now we are going to check for steps 2, which is initially 0. Now see, whenever we go to the first case, neither of the conditions satisfies. That is 5 lesser than equal to 4, nope. 5 lesser than equal to 3, nope. So we can just say that flag of 2 is also equal to 1, and since both the flags are 1, so we are going to return -1. I hope this is very much clear. Like, this was a very easy problem, but okay, the explanation. So if you are like still not getting it, so you can pay me up. That's it. Thank you.